right, looking at our third transformation for Chapter 9, our third and final transformation for Chapter 9, we're now doing rotations. So our three transformations are reflections, translations, and rotations. Those are the three. Typically, this one tends to be the tougher of the three because if you're a visual person, this can be very tough visually. So one thing that super helps with our rotations is to look at the rules that are going to take place. So as I look at my 90-degree rule, and we're going to be doing all of these, so don't worry. As I look at my 90-degree rule, here's what it says. It says to take your coordinates, which were AB, and in order to do a 90-degree rotation, we multiply the y coordinate by -1. So the y value is going to change signs. And then switch x and y. In other words, AB is going to become -b, A. So they not only trade places, but what was the y coordinate as it moved over into this slot also changed signs. And we're going to get plenty of practice with that, so don't worry. I'm just giving you the rules first. Our 180 tends to be the easiest because all that happens is both coordinates change signs. So what was AB is now becoming -A, -B. So just a sign change. What was positive would become negative. What was negative would become positive. And then the last one for 270 is very similar to the first one, only instead of the B value becoming negative, now it's the A value that becomes negative. So what was AB is going to become B -A. All right, so those are the three rules that we're going to apply. Again, it can be very tough to do this visually, which is why this is the one transformation that I strongly recommend knowing all the rules for. So here's kind of the way this is playing out. So if you see the original figure right here, here's W, X, Y, Z. There's the original figure. And what they did is they said, we're going to rotate this graph 270 degrees about the origin. What that means is, remember, the origin is 0, 0. That's right here. So this becomes our point of rotation. We're rotating around this point, and they want us to rotate it 270 degrees. So two things I want you to understand about that is, first things first, when we rotate, we always rotate counterclockwise. Unless it tells us specifically to do something else, it's always implied that we go counterclockwise. Here is 0, right? Here's where we're starting. So if I rotate 90 degrees, that would put me right here. So that's my 90-degree rotation. If I rotate 180, then I add another 90 degrees and it puts me right here. If I did another 90 degrees, puts me here. And if I did another 90, I would go full circle back to where I started at 360 degrees. So when they tell you to rotate 270 degrees, what they are really telling you is to rotate 3/4 of a circle. Or if you look at quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, they are telling you to rotate 3 quadrants, right? So what was here would go 1, 2, 3 quadrants and end up 3 quadrants away in the counterclockwise direction. So let's just look at these as how they applied the rule. So they took X, Y. Sometimes they use X, Y. Sometimes they use AB. Personally, I like the AB because I've seen sometimes students look at this and they're like, wait a minute, is this now my X coordinate or is this my Y coordinate? Well, obviously it's now the Y coordinate because that's the position that it's in. They're just telling you when you write it this way, it started here and ended here. So that's why I tend to like the AB rule instead of the XY, but either way, whatever makes more sense to you is fine. So here's what the 270 rule says. It says take your XY points, not only trade places with them, so you see how this was the -2, 4, so they traded places, and what was here, as it moved over into this slot, changed signs. So what was -2 became positive 2. So if you look at the point negative 2, 4 where it started, so here's negative 2, 4, this is where W started. If you rotated it 270 degrees, it becomes 4, 2, which is where it ended up. And notice as you went 270, it ended up 3 quadrants away from where it started. It was in quadrant 2, and it went to here, then to here, then to here, and this is where it ended up in a 270 rotation. If I physically took my paper, put my pen down on the origin at 0, 0, and if I physically rotated my paper 270 degrees, you'll see this point is now right there. So watch, when I go 90, it's here. If I went 180, my paper's getting in the way, it would now be here. And as I complete that rotation and go 270, now it's right there, right? And you can see where it ended up. See that point where it ended up? So keep that image in mind for just a minute. That is exactly where we are putting W prime, is in that location. So like I said, this can be very tough to do visually, which is why I recommend the rules for this section in particular. Let's try one on our own. I would like to give you guys the, I'm going to do this with a triangle. We're going to do all 3 rules. So here's my 90. Here's the 90 rule. So we're going to start, let's just plot these. So L is -1, -1. M is 0, -4. And N is -6, -2. If I rotate this triangle 90 degrees, in which quadrant would you expect it to end up? So if I go 90 degrees, remember that's going to move me 1 quadrant over in the counterclockwise direction. So let's see how this looks. So N, let's see if I can fit these in down here. Actually, let me put it here so I can make sure I keep all this on the screen for you. And you know what? I'm going to do this, because I'm not going to use that one anyway. So let me give you some room so you can really see this laid out nice and clear. So if I look at point L, which was -1, -1, let's apply the rule to get L prime. So if I apply the 90 rule said AB becomes -BA. So in other words, they're going to trade places, and when they do that, so these guys are not only going to switch, which is not going to change anything initially, but what becomes in this slot should now change signs. So as this -1 moves into this slot, it now becomes +1. And as this guy moved into this slot, it stayed as what it was originally, as -1. So if I plot the point 1, -1, sure enough, you see how L prime moved into this quadrant. And there's a new set of points. So M was at 0, -4. So these guys, again, let me write that as M prime. Keep my notation going. So M prime, again, these guys are going to trade places. So the -4 is going to go there, the 0 is going to go there. But as that happens, the guy that was my Y value, as it moves, is going to change signs. So that -4, as it moves, becomes +4. So M prime should be here. And again, you'll notice it moved a literal 90 degrees. Right? So it was here, now it's here. That is an exact 90-degree rotation. And one more point, we had -6, -2. As it becomes N prime. And if you want to pause and try this one real quick on your own before I do it. So as these guys trade places, what was in my Y slot, as it moves to the front, is going to change signs. So these guys are going to trade places. My -2 becomes +2. So n prime is 2, -6. Which is right there. There you go. So if, again, you physically put your pencil on your page and rotate your paper 90 degrees, this will now be here, right? If I were to rotate that 90 degrees, I'll try to do this without moving my cam too much. Actually, let me do it like this. So as I'm here, so what you're going to see if I rotate 90 degrees is this guy is now going to end up in that position. So if I rotate a literal 90 degrees, right, that's exactly what's happening. So this is now in the position of where I just drew my image. So like I said, very tough to do visually. Really helps to know the rules as we do this. So that was our 90 rule. Let's go to the 180 rule on the back side, which is where they simply change signs. So this one tends to be the easiest, I think, of the three, because it's just a sign change. All right, so let's plot the points. A is at -3,5. B is at 0,2. And C is at -5,1. So here's the original triangle. Which, by the way, this doesn't have to be a two-dimensional shape or like a triangle or a quadrilateral or something like that. You could do this with one point, right? It doesn't have to be multiple points. We're doing the more next level problem, but literally we could do this with one point. They could say take point A, rotate it 180, and that's all you got to do. Right, but we're just doing it with multiple points so you can see how this works out. More fun this way, right? So again, my 180 rule says AB becomes -A, -B. I literally just changed their signs, and that's it. So here's point A, -3,5. So if I just change those signs, -3 becomes +5 becomes -5. There's my new point. So at 3, -5, I get A prime. Again, notice my 180 rule reflects me, or sorry, rotates me 2 quadrants from where I started. It's kind of a nice way of just sort of checking your answer that way. If I know that if I ended up here or here or here, I know I did something wrong. So knowing how many quadrants you should move is kind of a good check to make sure you applied the rule correctly. Let's try it with point B. Point B was at 0,2. So if I just apply the sign change, it would become 0, -2. Obviously 0 can't change signs. So 0, -2 puts me here. Here's B prime. And again, you'll notice he went 90 degrees here, and then 180 to end up right there. And then last one, C is at -5,1. C prime. If I just apply the sign change, -5 becomes +5. +1 becomes -1. So at 5, -1, I get C prime. And again, guys, as you connect the dots on this, super, super important concept that we're going to make sure we get out of this chapter is the idea of isometry. And that is that all 6 parts of this triangle correspond and are congruent to all 6 parts of this triangle. So again, angle A prime is congruent to angle A. B prime is congruent to B. C prime is congruent to C. So all 3 angles are congruent and all 3 sides. This AB is congruent to this AB. BC is congruent to this BC. And AC is congruent to this AC. So all 6 corresponding parts are congruent. 3 sides and 3 angles. Last one, welcome to work ahead of me on this one. We're going to apply the 270 rule. Again, let's just plot points. So point P is at 4,7. Q is at 6.6. R is at 3, -2. And S is at 1, -1. So here is our four-sided shape. So we're going to rotate that figure 270 degrees. So here's the final rule. Is AB becomes, that was the third one that we did, AB becomes B negative A. So again, my coordinates need to change places. They're going to switch spots. But what was my X, as it moves into this position, changes signs. So like a point like 4, 7. Try to write small. I'm just trying to keep it all on the screen for you guys. So a point like 4, 7. Those guys are going to trade places. What was my X is going to change signs and become -4. So 7, -4 would put me right here. So there's P prime. And just like we expected, notice it moved 3 quadrants away because I'm now doing 270. So it's a simple check to make sure that we are on the right track at least. Q was 6.6. Oops. So they're going to trade places. What was in front, as it goes to the back, changes signs and now becomes negative. If it was negative, it would become positive, right? So Q prime is now at 6, -6. So here's my Q prime. And let's just finish off these last two and we'll be done. So R was at 3, -2. They're going to trade places, so that -2 moves to the front, my 3 moves to the back, and as that 3 moves to the back, it's going to become negative for R prime. -2, -3 would put me here. Again, notice the 3-quadrant rotation. And final point, 1, -1 for S. My -1 moves to the front, my +1 moves to the back, and as he does that, he changes to -1. And there's our new S. And if I connect the dots, this is the image that we get when we rotated the first one 270 degrees. So this guy rotated 270 degrees. And this is where it would end up. And literally, like I said, if you put your pen down on 0, 0 and rotate your paper physically 270 degrees, what will happen is you will see this now sitting right there, right? And so you can kind of look at it visually like that too, and that might help. But that is the end of 9.3.